factorizing by using completing square. So the general equation for completing square is this. So the coefficient of the x squared, so we take that as a factor out. So we factorize first, we take that one out, so that gives us so we only do this if the coefficient is other than 1, but if the coefficient is 1, it makes no difference. Let's have a look at an example where a scenario where the coefficient is 1. So let's say this. Let's say we want to factorize this expression. So our a value is 1, b value is 8, and c value is 7. So what we need to do is we have the b value. So this is what we're going to do. X plus b over 2. And this is our c value. If it's minus, we keep it the way it is. If it's plus, we keep it the way it is. So minus, that's always minus. And that's going to be, our b value is anyway 8. So I'm just going to put 8 there. 8. So that's basically 4 squared. So that is the same as saying x plus b over 2 squared plus c minus b squared over 2 squared, which is 4. So that's basically what we do here in order to find the turning point, and hence to find the value of x, we can use completing square to solve for x. So that gives us 4. And that gives us negative 9. So that's 16, negative 9. So the whole lot equals to 0. So we do this, and x plus 4 to the power of 2. Take the 9 out. So we get the square root from there. So that gives us x plus 4 So we take the square root on both ends, and that gives us x plus 4 plus or minus 3. So we take the 4 the other side. So that gives us an answer of negative 7 or negative 1. So that is when we don't have the coefficient, and the coefficient of the x squared when it is 1. So the x value is negative 7 or 1. So let's have a look at a scenario where it is other than 1. So let's find out that. So second example, completing square, factorize by using completing square. So let's see this expression. So I want to solve x using completing square formula. So again, we take the coefficient of the x squared out, so that gives, so the 2 out, so that gives us x squared plus 5 over 2, x minus 9 over 2. And now we use this the completing square. So we have this again, so it's going to be 2, x and plus 5 over, so half of the b. So b value now is 5 over 2, so times a half again, because we have to have it. So that's going to be 4, put another bracket, squared, minus 9 over 2, minus, and 5 over 4 squared, we'll put another bracket. And that 2, that other bracket is for the 2, because that 2 was the coefficient of the x squared, and we have taken that out as to be the common factor out. So now that gives us 2. If we expand this, we're just going to keep the 2 again first. So that gives us 8, 7, and 72 plus 25. So that's going to be 97. 97 over 16. To make it the same denominator, put another bracket again. Take the 2 out. 5 over 4 squared. I think this one you have to take this bracket out. So take that one out. So now go to here. So if I expand this, multiply the 2 we have taken out before, and put it inside, so that gives us to be, so 2x plus 5 over 4 squared minus, so that gives us 97 over 7, over 8 I should say. That halves it. So now again, in order to obtain the value of x, we take the common factor out. So we make an x the subject. So that's going to be 5 over 4, x there, 2 there, and take the number out. So divide 2 on both ends, so x plus 5 over 4 squared. So that gives us 97 over 16. So we get the square root on both sides. So we get on the left hand side x plus 5 over 4. That's going to be the square root of 97 over 16. So which gives me 4. So square root of 97 over 4 plus or minus. So we take 5 over 4 out. So therefore my x value is over 4. So that's how we do it if we have a coefficient.